Hello, my name is Sharon Benita. Today I am going to explain about additive manufacturing using deposition model. Additive manufacturing is a modern manufacturing process in which the object is created layer by layer with digital form. It is very useful. Additive manufacturing is very useful, and fuse deposition modeling is one of the most used manufacturing process in the entire world, because it is simple, cost effective and easy to operate, because this one has easy material suitability, which is very affordable for everyone. So it is widely used in every field, especially to print 3D printers. Fused deposition modeling is one of the important additive manufacturing process that are used in the industries nowadays. Now we are going to see about fused deposition modeling definition. It is basically an additive manufacturing process using thermoplastic, which is melt, and it creates layer by layer in the building platform. It is mainly used for educational purpose, function components and rapid prototyping and so on. Now I am going to explain this picture, which is 3D printing, the process. I am going to explain the full process in this presentation. In this filament spool contains plastic material. The plastic material is sent through the extruder. In extruder, the plastic material is heated and melted. The melted materials comes through the nozzle. Through the nozzle, it deposits layer by layer in the platform. After completing one layer, the machine moves downwards to complete the next layer. This process is repeated until the final product is achieved. This is how the 3D printing machines work today. And now I am going to tell you about process parameters. There are various parameters used in fused deposition modeling. It is very important to see if that parameters are in the printing machines or not. It is very important. I am going to tell what are the parameters and how much temperature it should have. Parameter is nozzle temperature, which is 180 to 250 degrees Celsius. It must have the typical value. Bed temperature 50 to 110 degrees Celsius. Layer thickness is 0.1 to 0.3 mm. Print speed is 40 to 100 mm per second. Filament diameter is 1.75 to 3 mm. These are the typical values that the parameters should have to be in 3D printing machines. And nozzle temperature is nothing but it controls the melting process of the filament or the material. And bed temperature is where it helps the printed layer to stick in this platform. And layer thickness, if it is thick layer, then the large thick layer, the speed timing is good. And if the layer is thin, the surface will be very smooth. And printing speed is nothing but the printing speed will increase. That is a main parameter in this. And the filament diameter, which is the diameter of the filament which comes through the nozzle. These are the most important parameters to see while building a 3D printing machines. Now I am going to tell about material suitability, which all materials can be used in 3D printing machines. PLA, because it is biodegradable and easy to print. It is used for educational purposes. ABS, which is strong and very durable, it is used in automotive industries and all everything. We will use that. PETG, which is tough and chemical resistance. The main thing is it has chemical resistance, so it is very important to use in the 3D printing machines. And lastly, nylon. Nylon, as you all know, nylon is very flexible and we can bend it like this, and it is also wear resistant, so we have to include nylon also. All the four materials is very important in fuse deposition modeling, that is 3D printing. PLA, ABS, PETG, and lastly nylon. These are the material suitability for 3D printing. Now I am going to tell the process of 3D printing from CAD software, how to print and how to bring final products from the CAD software. First we have to choose the desired material. Say for example a mug. If I want to give the final product as mug, means first I have to work in CAD softwares like SolidWorks or Fusion 360 and make the CAD drawing like this layer by layer. Then through slicing process it is separated like a thin layer on top. Then after slicing the printing picture will be ready, and then we have to do post processing, and then we will get the exact final product which we are taken as this mug. This is how we will do the original product from CAD, and then we'll take the same exact original product as the final product. This is very important material method to use to bring final products in the form of 3D printing. This is used widely in all over the world because it is easy and very efficient to print models like this and then to make a final product. Now I am going to tell about the advantages of fused deposition modeling. Fused advantages, it has many advantages to say. For example, low cost prototyping. It is very affordable, as I said before, and wide material choice. The thermoplastic has many range of wide materials. Simple operation. It is very simple. Basically a beginner can also do this, and rapid prototyping is used for quick testing and product development. It is very useful for product development based stuffs to do with fused deposition modeling. Now I am going to tell a few limitations on fused deposition modeling. Limitations are lower accuracy than other additive manufacturing method. It has slightly lower accuracy, and then visible layer lines. Visible layer line meaning is when we do layer by layer, suppose the layer is thick, it cannot be like smooth. It will be somewhat rough. That is what they are telling in visible layer lines. And limited strength in Z direction is some of the bond between the layers is weak, then we will call it as limited strength. And lastly, slow building speed for large part. Say for example, if you have to do like a big plate or something, if you have to do the large parts, it will take more time and also the printing machine will do it slowly only. Then only we can do all the layering process, then only it will be the surface will be smooth. So it has fewer limitations also. Fused deposition modeling as many application and industrial uses. Now I am going to tell few of the applications, industrial uses. We cannot specifically say they will use in this. In many industries they are using fused deposition modeling only. For example, I am going to say prototype in product engineering. Product engineering, product design all uses 3D CAD printers, printings only to make the product or object, I don't know, somewhat like that. And then make medical models and implants. It is basically and widely used in medical field nowadays. For the machines, for the doing operations, all the machines are made up of like some using fuse deposition modeling like 3D printings. It is very useful in medical field. And automotive engineering, it is used in automotive engineering, basically with tools. All the tools in the automotive engineering is made up of fuse deposition modeling only. And 3D CAD models, I told this process, like this process all the tools are made and it is used in automotive tooling. So basically, and next aerospace engineering also uses fuse deposition modeling. All the engineering, basically the physical engineering all uses fuse deposition modeling, that is 3D printing or from CAD printing, I don't know, anything, everything it is used in fuse deposition modeling. And it is also used for educational purposes. For example, it is used in schools and laboratories for the studying purpose. It is very useful in school labs and college laboratories. These are the application and industrial uses for fuse deposition modeling. Other than this has many advantages and many applications and industrial uses. Now I am going to explain this bar graph. This bar graph tells us about the effect of temperature on modulus elasticity. Modulus elasticity indicates the material stiffness. The material stiffness is very high at room temperature, as you can see. This is very high at room temperature, but the temperature when it is 50 degrees Celsius, it is comparatively low, and 60 degrees Celsius is fully low. This shows that material has a high stiffness when it is at room temperature. This graph also tells about horizontal printing, vertical printing, filament printing, injection molding. Injection molding is high when it is at room temperature. This graph shows the modulus of elasticity decreases as the temperature increases for all manufacturing methods. This graph is very important to understand fuse deposition modeling based on the materials used at room temperature and certain degrees Celsius. It is important to know this differentiation in order to make 3D printings and fuse deposition modeling. To conclude, I would like to say fusion deposition modeling is very wide. It has many things in the world and it is very useful. It is used in many industries. It is very cost efficient. It is very simple, easy to operate. Even beginners can learn it. And it is very helpful for doing 3D printings and in CAD laboratories. It is very helpful for this. It has many big future in engineering as well as product engineering. It is very useful than the other manufacturing processes. Other manufacturing processes are costly, more effective. It can't be used by beginners. It must have experience to be used. But additive manufacturing in fuse deposition material does not need any experience. Even a beginner can do it, and it is very easy. And material suitability is also very easy to find. It is very cost efficient. It is not that expensive at all. We can use this and we can design the printing machines with the help of this material, and the material should be taken in filament. Then only we can put it into the extruder and heat it and melt it. The material is chosen based on the strength and reliability and their efficiency. We can take the material and we can do the 3D printing machines. And this graph is mainly tells about how temperature and other things, modulus of elasticity, affect the mechanical properties of the material. Thank you.